So what does the transitive one tell you? In page number 2, look at the bottommost point. A relation is said to be symmetric. A relation is said to be symmetric if, for symmetric, a relation is said to be symmetric if A1 comma A2 belongs to R. After that, what did they put? Implies that A2 comma A1 also belongs to R. So, if I am able to find an ordered pair such that the elements of the ordered pair are what? A1 comma A2. If I say that this ordered pair is belonging to the relation, this is an assumption. So, what is it? This is not given in the statement. I am assuming that if something like this exists, then it should also imply this is a condition. So if I am saying T1 comma T1 belongs to that particular relation, then T2 comma T1 should also belong to the relation. What was the previous problem? I have set of all triangles. From the set of all triangles, I need to choose two triangles which are congruent. So you see, when I say assumption, I start with if. If I say T1 comma T2 belongs to R, then what am I trying to assume? I am trying to say that T1 is congruent to T2. Right? Tell me only one thing, guys. Is 1 comma 2 and 2 comma 1 the same? Though they are the same number, they are not same. Why? Because you swapped the ordered pair. When you plot them on the graph sheet, 1 comma 2 has a different representation from 2 comma 1. So here what I am doing is, if T1 comma T2 belongs to R, from this, can I conclude that T2 comma T1 also belongs to R? If I write this kind of a statement, what is the meaning of it? I am trying to say T2 and T1 are congruent. Congruent means they are same. So here, what did I assume? They are congruent, and this is leading me to the fact that T2 comma T1 also belongs to the relation. Hence, this relation is symmetric. Okay. Now, what is the third one? So, what is the meaning of this? If A1 comma A2 belongs to R and A2 comma A3 also belong to R, that should imply A1 comma A3 belong to R. If this condition is satisfied, it's very simple. 1 and 2 belong to R, 2 and 3 belong to R, implies 1 and 3 also belong to R. Okay. So here, using the same problem, this part, so anything which is before the implied symbol is an assumption, and anything after the implied symbol is a condition. Means, I am saying if I assume that this is existing, I should conclude that this is also existing. Okay, meaning if I write T1 comma T2 belongs to R, what am I trying to tell? First triangle and the second triangle in this ordered pair are congruent. Am I concluding or assuming? I am assuming. So that is why if. So actually you can put a double if also. Similarly, I am assuming that T2 comma T3 also belongs to R. So what is the meaning of this? T2 and T3 are also congruent. By me making this kind of an assumption, am I allowed to conclude that T1 and T3 belong to R? Am I allowed to conclude? Because first triangle and second triangle are congruent means they both are same. Second and third are congruent means they both are same. Right? So from this I can conclude that T1 comma T3 also belongs to R. So what is the meaning of this? It is reflexive, it is symmetric, and it is transitive. So hence it forms an equivalence relation. a relation, not a function. I hope it is clear, no? If you see, for the first time, I understand what is the difficulty, right? But you will be able to do it. Okay. So what is the next question? I will solve one question in less than 5 minutes. So can you tell me what is the next question? Example number 4. Examples 3, sorry. Let L be the set of, so L is a set of all lines.
And R be the relation in L.
So R is a relation in L such that you have L1 comma L2 such that
L1 is perpendicular to L2.
L1 is perpendicular to L2. Means if I write an ordered pair, the first line should be perpendicular to the second line. Okay. So for reflexive, R is equal to L1 comma L1. Does it belong to R? Right. Can I write L1 comma L1? What is the meaning of this? Can I write L1 comma L1? L1 is perpendicular to L1. So what is the meaning of this? You cannot write it. It's not reflexive because the line cannot be perpendicular to itself. So how will you write it? Since a line cannot be perpendicular to itself, what does it form? So L1 comma L1 does not belong to R. For symmetric, what should I do? What should I write for if L1 comma L2 belongs to R? What is the meaning of this? I am trying to say that L1 is perpendicular to L2. This is an assumption or conclusion? Assumption. Can I conclude that L2 comma L1 also belongs to R? So if first line is perpendicular to second, by default, second is also perpendicular to 1. So this is a conclusion. Yes, it is symmetric. Then what about transitive? Transitive, how many assumptions are there? 2. What are the 2 assumptions? If L1 comma L2 belong to R and L2 comma L3 belong to R, then what can I conclude? Belongs to R. I am writing it now. I have not yet concluded. L1 is perpendicular to L2. L1 is perpendicular to L2. L2 is perpendicular to L3. So how will it be? L2 is perpendicular to L3. Then how are L1 and L3? So can I say L1 comma L3 are perpendicular to each other? They do not belong to the set. Right. So what is the conclusion you can make from this? This particular relation is only symmetric. It is neither reflexive nor transitive. So is that what the question is? Prove that the given relation is. Now you understood, right?